Hey everyone, after a really long time, almost a year, I found something so exciting that I had to make a video and post it on my YouTube channel on how I actually did it. So here's a video that I'd like you to listen. This is around 2 years old video with a professional condenser mic. Now I'm of course using a different mic. So listen to this video of how my audio is just for a second. Name your project React. In an ideal situation, this is just a template example to show you. Here I'll do npm I to. So this is how my voice sounded around 2 years ago with a professional condenser mic. This is what I did. So I have got my blog and I have added a voice widget into one of my articles where the AI basically reads my article in my voice, and I did not speak a single word manually through this. So check this out. As a developer, understanding the rights you have over any code base is really important. So let's talk about something that many developers. That sounds so similar to what I how I actually speak and how I spoke on that particular video. So let me just walk you through on how I did this on my blog. Now here's a quick disclaimer. This video is not a tutorial. To keep the video basically short, I am not going to show you how I have built it entirely, but rather walk you through what were my steps, what is the APIs that I used, and how did I basically get to a point where I'll just in my article I just say audio is true, and my blog automatically generates this sort of audio that people can listen to. So to get started with, I found this really cool website called Replicate, and I've been playing with it during this weekend, Saturday and Sunday. And today it's now almost midnight of Sunday, and I was really excited to make this video, and here I am. Now, the model is called Minimax Voice Cloning, where you just give it a input file, right? So I took the first few minutes of this particular video, downloaded it as an MP3, cut around 4 minute 55 seconds. This particular model takes from 10 seconds to anywhere between 10 seconds to 5 minutes. So for maximum quality, I gave it 4 minute 59 seconds. This costs around $3 per output. So whenever I run it, it costs around $3. And it also, for me, when I gave it almost a 5 minute length input audio as inspiration or as for training, it took around 15 minutes, proper 15 minutes to actually go through. And when I ran it, it gives you something called voice ID. Here, note that you have two models. One is called Speech 2 Turbo and another one is called Speech 2 HD. Just remember to set this to Speech 2 HD, as the turbo one is really for speed, for inference speed. So it'll generate really fast, but it does not give you such good output when it comes to the cloned audio quality. So set it to speech to HD, and then you can just click on run, and that would just give you your cloned audio. Now, once it runs, it takes a good 15 minutes, and once it runs, you get voice ID. So I take this voice ID, and at the time of generating, I use a different model called Speech to HD. This is the actual, speech synthesis model. So I take this and I give it the voice ID here, the same ID like this. Basically, I copy the voice ID here, go back and paste the voice ID here. Then I put in the text that I'd like to. Oh yeah, one more thing that I would change here is from mono to stereo. I have realized that is producing much better audio. And yeah, that's pretty much it. Nothing else to change here. You just click on run. So I'll just run it here. This doesn't take a lot of time actually. It just generated in around 2 seconds. So it's pretty fast. And let me just play and show you how the audio sounds like.
Speech O2 series is a text to audio and voice cloning technology that offers.
Now I have an API key set up in my blog for this. So you just have to go to Node.js and it'll just simply give you steps on how you can actually install, use, and set up. The entire code is here for you. That's pretty much all I did. You just go to API and it'll give you the entire API docs, the keys, everything else. So it's fairly straightforward from here. Right now, let me just show you the blog code, how my blog is set up, so that you can actually see how I have implemented. So to get started, let's see actually how my articles are set up. So I'll go to articles folder. Here I have a bunch of MDX files. let's take the licensing, let's licensing article that I was showing you. So that is the article that I have. And here the most important thing that we need to look at is that we have set audio to true. There are articles where I don't have audio to true. For example, this one, it's too technical, and so it's not really, doesn't really make sense to have it as a audio article. So for articles where it does make sense, all I have to do going forward is add audio to true, and it'll generate that really soothing audio. So let me get you through how I am actually doing it. For all the articles that there is, I have a script. So let me go to scripts folder. Let me actually zoom in a bit for you so you can read it much better. So I'll go to generate audio. This is the actual crux of the program, right? So here's my voice audio, voice ID that that allows me to generate audio in my voice. And then so what happens is I initialize the replicate SDK. Then I initialize OpenAI SDK. Soon you'll know why I also have OpenAI or OpenRouter SDK. But the first thing that happens in this entire thing is finding out and deleting older, obsolete audio files that are actually generated. Actual audio files, if you look, are stored in the public audio folder, so they can be straight away accessed through Next.js, and they are hosted on Vercel itself, right? So first thing that happens is the cleanup process, where I get all the articles. Then I actually look through each single article, get their slug, read the article to know whether that article requires audio generation or not. Then for each article, I hash them. So you will see, for example, in this public folder, each file will actually have a hash at the end. So you can see this has a hash. This is just MD5. Uh, the way it works is that we don't want to generate the audio every time we sort of run the script, because that would just be waste of API calls, and it would also be very expensive. So what we do is we hash the content of the article. Here we produce a hash based on the content of the article, and then based on that we construct a path where the path is unique to the slug of the article and also includes the hash. So then we check if the file exists, right? If the article no longer requires audio, if or if it never required audio production in the first place, then we'd probably run through the cleanup process, where if we just delete all the audio files of that slug, so we don't store audio for articles that we don't need for. If it does require an audio, then we give it current audio path, so that doesn't get deleted, but delete all other previous obsolete audio files. So only the latest one is kept. And once that happens, we check if the current latest audio path exists, which means we are checking essentially if the latest version of the article has been made into an audio and that exists in the public audio folder or not. If it does not, then this if becomes false. If it is true, then we just say, okay, it does exist, it's up to date, we don't have to generate audio, we just move to the next one. If all our articles have up to date audio generations, then we don't have to do anything, the script just simply exists. Now, once it finds a script where it can proceed without continuing at this breakpoint, first thing that we do is we use Claude Sonnet 4 through OpenRouter and actually give it this particular prompt where it only responds with the actual prepared content. It only outputs in plain text, because once we give it to the audio model, the input article is actually written in MDX, as you can see, which is basically Markdown plus React components within the article. So we don't want to give it as it is to the audio generation model, because then it would just read out the JSX tags. So in that place, we would tell the model, Claude, in this case, Claude Force on it, to actually produce plain text instead of the raw input that we give. Then we also tell it, in place of links, URLs, mention it to refer the written article, because we don't want the audio file to contain, for it to read a big long link for 5 minutes or something like that. Then what we do is we tell it to convert the audio into a conversational tone. Now, the beauty of it is we are not just converting the text of the article into audio, we're actually changing it slightly so that it's more like a podcast than actually a regular audio. So if you look at this, for example, this audio contains some links, it contains some accordions and stuff, which are now, in this case, very neatly converted into a format where it is easy for the user to actually listen to the article rather than just read. So this is that line, and then we say add subtle cues. For example, imagine this. This I have realized increases makes the audio much more interesting and increases the probability of the user to have it listen completely till the end. The end goal is for it to produce a podcast like audio rather than just reading out the entire article. So that happens. And then, yeah, one more last thing that we do is we also tell the AI to add pound symbols. This is a specific syntax. Let me show you how it looks like. It looks like this, where this syntax is understood by the audio model, which actually produces proper pauses. So instead of relying completely on the audio model to infer on where to pause and how much to pause, the Claude actually tells the audio model in certain cases by putting up explicit pause tokens basically. Once this happens, the last thing that we do is we say if the article is above 500 words, somehow summarize it. Maximum try to put 2 to 3 minutes, as we don't want a really long audio podcasts. And then the last thing that happens is we just give it the actual content wrapped in article XML tags or sort of HTML like tags, so that the model clearly knows what is instruction and what is article. Once that is over, Claude responds with actually the changed version, the modified tweaked version of the article. This is when the actual fun begins, where this is where we give it to replicate using the Minimax speech to HD model. We tell it what is the pitch. These are all the standard things that that I've shown you in the UI in the playground just a few minutes ago. The only thing that we change here is stereo, and the voice ID is now instead my voice ID that is coming from the top of the file. Language is English. And here is one thing that I did. So somehow when the actual audio gets generated, it starts way too quickly, in certain cases clipping off the beginning few seconds of the audio. To solve this, I have explicitly added 1 second gap, so that the audio that is generated has some blank space at the beginning, so it doesn't get clip off. Then all I do is just straight away plug the LLM response from Claude into the audio generation. Once this audio is generated, we get a blob. We take that blob, convert it to a buffer, and write it to the audio path, and just simply log that the audio has been successfully generated, and we just move on to the next article if there is. Otherwise, we just say end. So this loops through every single article, filters out whichever articles that need audio, checks if the audio needs to be updated or not based on the content hash. Only if it actually needs to be updated does it really generate new audio. So without doing any changes, if I just run the script for you in my terminal just to show you, just hang tight. Let me just zoom my terminal. Now, if I run audio, it should not generate. So you can see it's pretty fast. It says just all of the articles are up to date. So now once the audio files are generated, we have done 50% of the work. Now, the other 50% is how do we actually show the component that I was actually showing you in this article, like this one. We don't embed a tag in the actual article content. So how do we do that? So let's go through that. So for that, what I am going to do is I'm going to open up the Slug page, go to the page component, and here you will see that this is a proper React component, RSE component, server-side rendered, which first gets the article from the slug. So it looks at it gets the article, actual article content, and also it gets the audio content only if the article's meta says this article has an audio attached to it. Only in that case, we actually run the get audio function. Now, the get audio function, here the challenge that we are trying to solve is that is going to have a hash. Now, the article will not know what is its hash, its own hash. So somehow it has to guess. So here, the solution that I came up with is to use glob, where I say find out all files where the slug matches, but it has a dash at the end, and then there is a star, and then it ends with a MP3. So if the cleanup process that we had earlier ran successfully, at the time of generating, at the time of Next.js building its page, it would only ideally end up with one file that matches the slug of the article, and the ID is automatically inferred because of glob. So when that happens, we get the file, we only get the file's base name, since we only want the actual MP3. and then we return /audio/file name because the audio is already in public folder. We want a link that allows the actual Next.js site to play the audio. So this is the actual server URL. So you get this string. So if I hover, you can see it's string or false or undefined. So false and undefined are basically falsy, and string is actually truthy. So what happens is that when I actually render a component, I say conditionally render this. So if audio file is either false or undefined, then nothing gets rendered. In the case where the actual article says audio to true, and then we also were able to find an MP3 file, then the audio player component actually gets triggered. This is still happening on the server. Gets sent as a prop the audio file. Now the actual audio file you will see is a client component. It does not actually render on the server, essentially transmitting the actual audio MP3 file, including the hash from server to the client. Now, when that happens, the library basically called use React audio player, which simplifies things essentially and renders out this nice little, player UI using the purple play pause button. And then you have backwards 10 seconds, forward 10 seconds. How much did we listen to till now? And how long is the audio file? That is exactly how I got AI to read my articles in my own voice for me. So yeah, that is pretty much it. I was very, very excited about this, and therefore I wanted to make a video so that you all can get some inspiration on how to do. I feel like we should keep learning. Whenever we get some time. This Saturday, Sunday, I got some time to experiment, play with something new, and I felt like this is something really exciting and wanted to show it off to you. So yeah, that is pretty much it for this video. Subscribe to this channel for more videos like this whenever I find cool stuff. And thank you so much for sticking around for 20 minutes with me. So yeah, have a great day. Bye bye.